We would like to find the exact area for the surface or the surface area obtained by rotating this curve about the x-axis. So from our formula, when the function f is positive and has a continuous derivative, you can find the surface area from this formula. The surface area is the integral from a to b, 2 pi multiplied with the function f of x, and again, where f is positive and has a continuous derivative of the function f, and then multiply by the square root of 1 plus f prime, the first derivative f prime of x, and everything square, and dx. Now, if the curve is described in terms of y, like this example, then we can also rewrite this integral as the integral from c to d, and then 2 pi, and multiply by y, and multiply by 1 plus dx dy. Instead of dy dx, now it's dx dy square dy. So again, we use this formula whenever the curve is written in terms of y. Okay, so well, the first step that you would want to do is to find what is your dx dy, right? We want to take care of the stuff under the square root first, just like the arc length problem. Now, according to the x equation, I can find dx dy by using the power rule. So I will bring the 3/2 down, and then subtract 1 to the exponent. So 3/2 minus 1 is 1/2. And then I multiply by the chain rule, which is the derivative of y squared plus 2. That is 2y, right? Because we bring down the 2 and subtract 1 to the exponent. And you can actually cancel the 3 and the 3 right here. So it's actually 1/2. So let me just clean it and then simplify everything here. And as you can see, we can also cancel the 2 right here too. So I'm going to move the y to the front. So we actually simplify the expression. And then now I still have to add 1 to it, like right here. So 1 plus 4 dx dy square, that will be 1 plus, and then I have dx dy, which is y squared plus 2 to the 1/2 power, and then everything square, and that will be the y square, and then I know that the square of the 1/2, that will cancel the 1/2, so you get the first power, which is y squared plus 2 to the first power. And then I'm going to distribute the y square to the inside terms. So I'll get my simplified expression to be y to the 4th power plus 2y squared. Okay, so that will be my expression, and as you can see here, you can actually simplify it one more time. This is the perfect square trinomial of the y squared plus 1, everything square. So a plus b square, it is a square plus 2 times ab plus b square. Now, I'm going to go back to my formula right here. So we're gonna begin to substitute everything to that formula. So we have 2 pi. I'm going to bring the 2 pi outside. And then we know that the y, the dy, it is running from 3 to 5. So that would be 3 to 5. The y will stay as the y because everything is written in terms of y. And then we have the square root of the entire 1 plus dx dy square. We just got that right here. So it's y squared plus 1 and then square. And then dy. And you can see that we have the square root and the square. So you can cancel that and then get out the y squared plus 1 only. And now it is becoming a very simple calculation right here. It's just a simple power rule. So I have to simplify one more step. Multiply the y inside, so y3 plus y, and then dy. And finally, applying the power rule, y4, add 1 to the power dy by 4, and then add 1 to the power y squared over 2, and then go from 3 to 5. And now I'm ready to plug in the 3 to the y, 3 and 5. So 5 to the 4 power over 4 plus 5 squared over 3. And then do the minus and then plug in 3 to y. 3 to the 4 power over 4 plus 3 squared over 2. Oops, this one should be 2. Okay. And yes, at these steps, you should be able to use any calculator to get the final answer. And if you do it correctly, you should get 288 pi. So this is the surface area for this curve that is rotated about the x-axis. And this curve is described by this function in terms of y from 3 to 5. For this problem, we want to find the surface area of this curve revolving around the x-axis and also the y-axis. But in this question, it's only asked you to set up the integral, and you don't have to evaluate the integral. So it is a little bit easier compared to the last problem. So let's try to graph this curve. So we are given the curve y, the root 3 of x, or you can rewrite that as x to the 1 over 3 power. And I can graph this curve. It looks something like this. Oh, let me erase that. Something like that. So this is x to the 1 over 3, and this is the y, and this is the input, the x. And we are only restricting the x value from 1 to 8. So maybe 1 is around here, and then 8 is here. So we are only focusing on this interval 1 to 8. So when you rotate this one with respect to the x, that means you are rotating the entire curve around the x-axis, and then you want to find the surface area, the outside area of this curve when it revolves around the x-axis. So we're gonna use the same formula just like before. The formula will be the integral of 2 pi multiplied by y and the square root of 1 plus dy over dx square and then dx. Again, with respect to x, so I expect this is to be the dx. And again, it goes from A to B in this case. So we are focusing on the x-axis. So it will be from 1 to 8 because we move on the x from 1 to 8. This is the region that we want to find the surface area. So first, I want to take the derivative dy dx using the power rule. So we're going to bring down the 1 over 3 and subtract 1 to that. 1 over 3 minus 1, it is minus 2 over 3. And now I want to find the 1 plus dy dx square. So this is going to be equal to 1 plus dy dx, which is 1 over 3, x to the minus 2 over 3, and then we square the entire thing. Okay, so 1 over 3 square, that will be 1 over 9. And then when you take this term to the power of 2, you actually multiply the 2. So that will be x to the minus 4 over 3 power. Okay, so we have everything. I'm going to go back to, actually, I'm going to take the square root. Let's simplify everything on the side before we plug into the integral. So 1 plus the dx, dy dx square, that will be 1 plus 1 over 9, and then x to the minus 4 over 3. Alright, so I'm going to go back over here. We know we go from 1 to 8, and then 2 pi. Remember, we still have the y right here, and that y is actually this function. Everything must be in terms of x. So this is going to be x to the 1 over 3 power, because that is the function of y. And we multiply by the square root of 1 plus 1 over 9 and x to the minus 4 over 3 and dx. So this is how you set up the integral, and the question does not ask you to evaluate that. We only set up the integral with respect to x. Now the second part is when the curve is revolving or rotate about the y. So this time it will be flipping around, rotating around the y, and we want to see what is the surface area. Now the formula will be the same. S will be equal to, in this time we are using the dy because this is respecting to y. So we will go from C to D instead of A to B. I'll use the different values, C to D. And this is again 2 pi y, and same thing, the square root of 1 plus, and this time not dy over dx, but dx over dy square. And the outside, the differential must be dy, the same letter y. Okay, so our function is still the same. We have y equal to the radical with the root of 3 x, and our goal is to find dx dy. So I have to solve the function for x first. So what I do is I'm going to raise both sides to the third power. So I have x equal y to the third power. And then now the function is written in terms of y. I can find dx dy using the power rule. So I bring the 3 down and then subtract 1 to that, will give me 2. And then I can find 1 plus dx dy, so dx over dy square, that will be 1 plus 3y square, and then everything square. And this will be 1 plus 9y to the 4th power. Now go back to this formula. There's one more thing you have to do, is that you have to change the limit of iteration with respect to the y. Remember the 1 and 8, this value was for the x, but now we change to the y, so it has to run on the y axis. So I'm going to use the function right here, x equal y to the 3rd power. You know what? Actually, I'm going to use the other one, y equal the root 3 of x. Now, before we went from 1 to 8, so when my x is 1, then my y will be the root 3 of 1, which is also 1. And then when my x is 8, then my y will be the root 3 of 8. That will be 2, because 2 raised to the 3rd power will be 8. So instead of going from 1 to 8 for x, now it's on the y, so I'm going from 1 to 2 instead. 2 pi, the y right here stays as y because everything is written in terms of y, so you don't have to replace the y with the function, the radical, the root 3 of y, of x, but you keep the y right here because everything is in y now. And then the square root of 1 plus dx dy square, that will be this term right here, 1 plus 9y to the 4th power. And of course, this is going to be dy. So this is the final integral that represent the surface area of this curve when rotating with respect to the y.